Hello, thank you for tuning into this video focusing on data containers and Python pandas. As many of you know, in the data analytics space, we simply are living in the age of big data. Where, be it the sheer volume of data in magnitude, frequency, and formats, namely volume, velocity, and variety, we're receiving data, and we have to essentially manage it. And so this video is really going to focus on a technique in management for you to help users interact with many similarly structured data sets. And that's namely saving pandas data frames in built-in Python lists or dictionaries. And I'll be illustrating this further with example data pulled specifically here from the National Snow and Ice Data Center out of the University of Colorado Boulder, where they store NOAA's Arctic and Antarctica Sea Ice Index. And it's available here at this URL. After importing our tools here, we'll be using helper tools to interact with several objects, our data stacks, NumPy pandas, and our graphing tool and a modeling tool to help with a graphing format. The traditional way of really interacting with many, and so this National Snow, Sea, and Ice stores data from two different sites. Here's the FTP, and it's separated by the north and south hemispheres. And the data is really at a monthly aggregate level, separated by those north and south, 1 through 12, and 1 through 12 for both sets. And essentially, you're working with 24 data frames just to interact with this sea ice index. And the traditional route for many newcomers in this in pandas will be to create a data frame for each corresponding CSV file. And so you'll assign named objects to the output of read CSV. And so here we're essentially illustrating that with 1 through 3 abbreviated, and then the 12th 1 through 3 again, and abbreviated with a 12 for the south. And it's showing, and then a quick output of what's in our environment. And we can see a lot in addition to our module aliases. We also have the data frame objects, and through the ends versions and the S versions. Now obviously it'll extend out to all 12, and for small objects this will be a small number of elements. This is trivial. However, this can really become very enormous setup if you say working with 50 US states, or over 150 world countries, or even further granularity, counties and provinces, and or even by year data sets. And so you can quickly see that this becomes a very monster essentially in magnitude to manage. And more advanced users will probably do this in a more dynamic format, still following the traditional approach of really creating separate objects for corresponding input files, but a more dynamic route using a global system object, where instead of manually assigning, you'll dynamically assign by indexing this global object to assign it to your value. But this breaks the functional programming of working with data objects, where you're really essentially going the back door to change your environment. This is not advisable. You don't want to start using system variables to really go a dynamic, and then you can even set up runaway scripts and really blow up your memory space going this backdoor route. And then still it's tougher to debug and really maintain a nice, clear, maintainable code base. And so you really want still a different approach to this. And the really emerging approach for this challenge is really to interact with a single data frame list or object of many data frames. This avoids the global environment of many separate objects. You serialize data elements now in indexable format for easier organization and management. And you really eliminate and streamline a lot of repetitive and tedious code for readability and maintainability. So this approach, this code here is really the alternative approach. You essentially create a list of your URLs or links to your those composite of data sets, CSV files. Here's just we're setting up the prefix because we know that the format of the tail end of the file name. But we're really building a dictionary through a dictionary comprehension, where we're iterating through all those prefixes and then storing them accordingly. And so we end up getting a dictionary of 24 data frames, each with their key that we can essentially access. And so we then take advantage of working in this a better setup. Data frames within lists are now available through indexable references. No longer do we have to recall from our environment going the globals route. And then there's really no loss of functionality or attributes or properties. A lot of newcomers are afraid of storing data frames within a different structure because of that. But rest assured, all your objects retain their properties and attributes, and then you can further standardize operations. And here's examples of that. We can still call head even though the data frame is stored within a dictionary. Here's the first 5 of the N01 data set. The S01, the tail, the last 5 rows of the S0 data set. We can look at the shape, rows, and columns of still another object. And 12, we can look at the D types, columns, and their corresponding data types, so that's 12. And then we can streamline and iterate across all elements of that dictionary. We're going to look at the describe call. And so we do just that. We output all of the describe commands of all 24 data frames within that dictionary. And so, we can quickly get a nice dashboard, look at slice and dice of our data sets easier with interacting with that larger single dictionary object, rather than having to bind all these up and running them had they been stored in separate objects. And plotting overall becomes more streamlined and easier. Here we're going to create a grid 8 by 3 for all 24 months, 12 per hemisphere. And so essentially iterate element wise through each of the subplots and the data frames within that dictionary. Call a dynamic plot title, for their corresponding region as well as month. And then we call data frame plot, a line plot of our 2 numerics, extent, area by year, and see how those compare across time. And so we get a nice grid output, really all leveraged off of you working out of that dictionary of data frames, rather than the laborious aspect of calling those line by line or having to bind them up on the back end to run this iterative process. So here's showing the Arctic sea ice extended area across time sliced by the months. And we can obviously see, as the literature shows, the pronounced decline of areas sea ice in the Arctic and Antarctica as well, shows it's a varying trends across time. So again, you can do very sophisticated operations working out of a larger container of your data sets. And finally, we can just better streamline compilation, right? We ultimately want to interact on the entire data set, even though they came from separate files. Pandas has a nice command, concat. This allows, it takes in a list or a dictionary of Pandas objects, be it data frames or series. You can vertically concatenate or you can horizontally merge to get a larger data set overall. And so we do the vertical, the default append, and get a single data frame overall over 1,000 rows by 6 columns. and see how their varying data types. We can now run a single head and tail of that entire data set, and then we can even go further and run a single time series plot. Now that we have all months together, we can run an Arctic and Antarctica. We can even output that single data set as well. So again, we're being facilitated from interacting with the original container, to really streamline and build our entire spectrum of data operations. And so graphing, we can now graph all days together, show a cyclical activity, obviously due to seasonality, but then we can run a seasonal decomposed line of both sea and extent and area across time. And obviously we're seeing that has small noticeable downward trend across time, as the literature shows, due to the climate factors. And then similarly, we can do likewise with the Antarctica sea ice region, showing its cyclical activity of sea ice extent and area, as well as the seasonal decomposed trend across time. So, overall, I hope I was able to really show the power of using data containers in the Pandas environment. Anytime you're working with many data sets coming from various sources, you really want to better organize yourself by avoiding defining many objects in your global environment, but really interacting with one overall large container for your data elements. And thank you so much for your time, and hope this helps.